Hi class, so this video is also about the areas between curves. Now what happened last time, I mentioned that we need to know which one is the upper boundary and which one is a lower boundary, because we're going to take the higher, subtract the lower. But what if we have two different curves and they are so one of them is higher in one interval and the other one is higher in the other interval. So what are we going to do about that? So that's why we have to know the graph, and we know which at that particular region, which one is the top one and which one is the bottom one. So make sure you know the curve well. So for example, cosine and sine is curvy like this, right? So when they ask you to find the area of the region bounded by those two curves, the most important thing is the interval. Now they give you the interval right there is 0 to pi over 2. So as you can see, from 0 to pi over 2, things change, right? So like I said, it helps if you know the curve. If you know the curve well, then we can proceed with the problem. Anyway, so from, okay, so first of all, let's take a look at the point of intersection. So the points of intersection. That means you have sine of x equal to cosine of x, right? So when that happens, that's when x equals to pi over 4. Right here, right? Anyway, so make sure that you have to observe, right? So cosine of x greater than sine of x when we have x in between 0 and pi over 4. But sine of x is greater than cosine of x when we have x in between pi over 4 and pi over 2. Okay, you can see the graph right there. Anyway, we're going to have to do two different integrals. So from 0 to pi over 2, we have to break it, right? Cosine of x minus sine of x. I have to put the absolute values right there because, like I said, we're going to have to break it into two different intervals. Pi over 4. And from 0 to pi over 4, cosine is greater. So we have to take cosine of x minus sine of x dx. And then for the other one, pi over 4 to pi over 2, it's the opposite. We take sine of x minus cosine of x dx. All right, and then from there, you evaluate. So we have sine of x plus cosine. I'm taking the antiderivative, okay? So that's why we have sine of x plus cosine of x for 0 to pi over 4. And now this one right here, we have to do negative cosine of x. Like I said, antiderivative from pi over 4 to pi over 2. Okay, so from there, you should know the values. So what do we have here? We have 1 over square root of 2 plus 1 over square root of 2 minus 0 minus 1. And then for this one, we have, I know it's kind of silly if I put negative 0, but let's just do that. Minus 0 minus 1 plus 1 over square root of 2 plus 1 over square root of 2. Okay, so we ended up with 2 radical 2 minus 2. That's the exact values. Okay. All right, let's take a look at the next problem. The next problem, we have a line, a straight line, and the parabola. So let's try to graph it. Okay. So what I have is y equals x minus 1 is gonna be like this. Right? And then the other one is the parabola. So something like this, sideways. Okay. All right. So here's the problem. As you can see, now we don't have top, bottom, but we have left and right, right? And if you want to evaluate those two, of course, we have to find the points of intersection as well. So I'm going to set them equal to each other and solve it. So if I set them equal to each other, x, so what I have right here is x minus 1 and then the other one I have is y squared equals 2x plus 6. All right, I need to use substitution. So I'm going to solve for x here. So x equals to y plus 1. So y squared is going to be 2. Instead of x, we have y plus 1 plus 6. So y squared is going to be 2y plus 2 plus 6 is plus 8. Okay, so y squared minus 2y minus 8 equals 0. Therefore, y minus 4, y plus 2 equals 0. So I have y. Y is 4 and y is negative 2. Now, like I said, let's go back to so if you can see right here, the point, and if you want to write down the coordinate, this one would be 4, and then you plug it in for y, 4. So that's one. This one should be 5, 4. And then you plug it in for the other point, you should get negative 1, negative 2. All right. But like I said, now we have left, right. We don't have top and bottom. So for left, right, you will get the area. Now, since we sliding this way, so I'm gonna cut, I'm gonna have the strip like that, this way, right? So it's cutting the y-axis. So when you integrate, it's gonna be dy instead of dx. So the area is gonna be from C to D, and then we have the curve the right curve and the left curve of dy. Okay, so notice now we're going to integrate in terms of y. Therefore, you cannot use the original equation because the original equation, x is independent. Now we want we want y to be independent. So you're going to have to solve for x. Okay. All right, so I'm going to solve for x. So now we're going to have to solve for the left and boundary curves. So the right is going to be x equals y plus 1. So earlier we have, let me just put it right here, y equals to x minus 1. So x is going to be, xr is going to be y plus 1. And the left, okay, let me check the equation earlier. What do we have? Y squared equals 2x plus 6. Y squared equals to 2x plus 6. All right, so I'm going to solve for x now. So it's going to be y squared minus 6 divided by 2. Okay, so if we simplify that, we're going to end up with y squared divided by 2 minus 3 for the left curve. Now we're ready to plug it in. So now, okay, I'm going to have the curve. So make sure you take right, subtract xr, subtract xl, dy. Okay, and then you have to be careful with the integral as well. So now we consider x, okay? So I'm sorry, we dealing with dy. So you're gonna have to use y, not x. So I'm gonna have -2 to 4 for y, because we're dealing with dy here. So dy, so let's say the function, which one is the right? Which one is the right one? So it's y plus 1 is the right one. Y plus 1, subtract the left. Y squared divided by 2 minus 3 dy. And then from there, we simplify, we integrate. Okay, so let me simplify first. So what do we have here? -1/2 y squared plus y. And then we have 1 minus -3, that's plus 4 dy. All right, now we take the antiderivative. -1/2 y cubed over 3 plus y squared over 2 plus 4y. And then we integrate from -2 to 4. Okay, and then you plug it in. -1/2. So what do we have? We have 4 cubed, which is 64, over 3 plus 16 over 2, so it's 8 plus 16 minus, what do I have here? So I have -1/2, and I have -2, so that's -8 over 3 plus 4 divided by 2, that's 2 minus 8. All right, So we calculate everything, we ended up with 18. All right,